What is a buffer? Well, that's something that we're going to answer in this slideshow. Another thing is that we're going to have a comparison of an acid and a base in the solution and the concentrations of ions in it. But first thing we want to do is answer, what is a buffer? Well, we define a buffer as a solution that resists the change to pH when you add acid or base. Most buffers are made of a weak acid with the conjugate base, in which we have a lot of the weak acid in solution along with a lot of the salt of its conjugate base. And this sets up an equilibrium that's heavily weighted on either sides. What we're going to do is we're going to look and see why the buffer resists the change in pH. Let's first look at this. When we construct a buffer, it's going to be a weak acid and its conjugate base, both being in solution, and the base comes as its salt. That means that we're going to have a lot of this and a lot of this. Okay? What it's like putting two big elephants on either side of a teeter-totter, and what you're going to do is add a little bit of something to one side. That the weight of the elements is so great that adding a little bit of something to it doesn't make the teeter-totter tip. And that's what we're actually looking at. We have a huge amount of this and a huge amount of this, and we add a little bit of acid. Well, some of this is consumed, and it makes this, but because those concentrations are very large, what happens is this doesn't change much, and this doesn't change much, and when you add this in there, it consumes this and shuttles this over there, but the proton concentration actually ends up being the same. Likewise, if I add base, this is going to be reduced. Well, a little bit of this is taken away from the huge amount and makes a little bit more of this and adds it to the huge amount. Basically, there's no change. What I'm most interested in you understanding is how the blood buffer system works. The blood buffer system is one that is made by your body by the amount of carbon dioxide that you have in there. You have a huge amount of carbon dioxide in your bloodstream due to metabolism, ongoing and constantly making carbon dioxide. Of course, as you make it, you breathe it out. When carbon dioxide is made in your bloodstream, it combines with water to make carbonic acid right here. Oh, you can't see it here. Hold on. Okay, so when carbon dioxide and water combine, they combine to make something called carbonic acid, which is a weak acid. There's already a huge amount of bicarbonate in your bloodstream. And so right here, the carbonic acid and the bicarbonate end up being a weak acid buffer because you have huge amounts of them all. This carbon dioxide amount therefore controls the pH in your body. You actually have a sensor in your brain that is constantly tasting to see what the proton concentration is. And when proton concentration goes up, it says, wow, you're making lots of carbon dioxide, let's breathe more. When your proton concentration goes down, your sensor says, wow, you are breathing too hard and getting rid of too much carbon dioxide, let's slow your breathing down. So this is actually how your breathing is controlled, is through this proton concentration testing to see how much carbon dioxide is in the water through this equilibrium. But the amount of carbon dioxide is also related to the pH of the blood. And we can actually find out what happens when your pH gets messed up, what happens to this equilibrium. Let's look and see what happens to this equilibrium. I've taken the carbonic acid out of the middle and just show the two ends of the equilibrium. Carbon dioxide and water gives proton concentration and bicarbonate. When you have some a lung disease, or maybe you don't breathe enough, maybe you hold your breath, what happens is this equilibrium gets overloaded because you start retaining the amount of carbon dioxide in your lungs and also in your bloodstream. If you increase the amount of carbon dioxide past the normal, what happens? You start building up proton concentration in your blood and your pH drops. So what you find is your carbon dioxide level is very high and your pH is high. And because this is caused by a respiratory issue, they call it respiratory acidosis. If you hyperventilate and you expel too much carbon dioxide, what happens is the carbon dioxide level starts getting very low. That's going to cause the equilibrium to shift over this way, and you're going to have it's like taking away carbon dioxide. You're going to have less protons and less bicarbonate. The proton concentration is going to lower, so that means your pH goes high. So when you have a low carbon dioxide concentration and you've got a high pH, we realize it's caused by a respiratory problem, and we call it respiratory alkalosis because alkalosis means more basic. Okay, now what we're going to do is we're going to compare an acid and a base together and do it side by side so that if you have any confusion about what ions are being produced in solution and why we have pH of certain numbers, you take the negative log of certain numbers, this might clear it up. So we're going to do 0.03 molar hydrochloric acid and 0.03 molar sodium hydroxide side by side. These are the dissociation equations. Notice the acid makes protons and the base makes hydroxide. So my concentrations of protons are determined by the concentration of the acid. So my proton concentration is 0.030. My hydroxide concentration is determined by the sodium hydroxide solution concentration. So it's 0.030. The same numbers, but it's different concentrations. Notice the sodium hydroxide gives you the hydroxide concentration, and the hydrochloric acid gives you the proton concentration. Let's put them in their proper places. Hydroxide down here and proton up here. Now what we're going to do is we're going to figure out the other values. To figure out my proton concentration over here, I'm going to use this equation. To figure out my hydroxide ion concentration, I'm going to use this equation too. I just rearrange it differently. Over here, I make it proton concentration is 1 times 10 to the minus 14 over hydroxide. And over here, I'm going to make it hydroxide concentration is 1 times 10 to the minus 14 over proton concentration. I plug in my values, and this is what I get. Notice how they're flip-flopped. Why? Because this is a base and this is an acid. They're making different ions in solution. Now when I go to take my pH, what do I take my pH, what do I take my negative log of? I do not take it of this. I take it of this value. When I take my pH over here, I do not take it of this. I take it of this value. And so my pH in the sodium hydroxide solution is 12.5, and my pH in my proton solution is 1.5. And now, hopefully, you'll see why there's a difference, why we must look at what we're looking at the concentration of because it determines what the ion concentrations are. Be sure and do problems. Do the in-text problems as you read. Do these end-of-chapter problems, and make sure that you don't do the same problem one after another, or you'll just be relying on memorization. Memorization won't work in chemistry. What do you have to do? Mix up those problems so that you get a different type of problem each time. Then make sure you do all the worksheet problems, and when you get through with that, go ahead and do your online quizzes. Phew!